This is AS1 January 04, question 4a, and it's a question about projectiles. A ball is projected with velocity v at an angle theta to horizontal ground. Figure 4.1 shows the path it follows. Air resistance is neglected. Complete figure 4.1 showing what happens to the magnitudes of the horizontal and vertical components of the velocity of the ball during different stages of the flight of the ball. Used phrases like increases steadily, remains constant, and decreases steadily. And it's broken up into between P and Q and then between Q and R. So if you have a wee look at the first half there of the projectile motion, the vertical velocity is going to decrease because it's slowing down due to acceleration due to gravity. So it's going to decrease steadily because there's a constant deceleration till it gets to here. The horizontal velocity never changes, so it remains constant. So we're going to write in here that the horizontal velocity remains constant and that the vertical velocity decreases steadily. And then between Q and R, if we look at that half then, you can see there between Q and R that the vertical velocity is going to increase steadily because it's subject to acceleration due to gravity, and that the horizontal velocity is still going to remain the same. So it remains constant. This is the horizontal velocity. And then the vertical velocity increases steadily. The range r of the ball on level ground is given by the equation r is equal to v squared times the sine of 2 theta, all divided by g, where g is acceleration of free fall. For a given speed of projection, for what value of theta is the maximum range obtained? So the maximum range is always obtained when the angle is 45 degrees, and you should learn that. That's whenever you get your maximum range. On figure 4.2, sketch a graph to show how the range depends on the angle of projection for a given speed of projection v. Hint, refer to equation 4.1 and use your knowledge of the sine theta, of the sine function. So there's the equation. R equals v squared the sine of 2 theta, and it's divided by g. Okay, so theta is going to go up from 0 up to 90 degrees. Whenever you get to 45 degrees, you're going to have your maximum range. And so if we mark out 45 degrees there, 30, 40, 50, it was halfway between there, so we've got a maximum range. And because a sine wave has got this shape of wave, then, and it's really just the first part of this graph we're drawing, then that's what we're going to draw here too. It's going to be dependent, like that. Suppose the velocity of projection is doubled, but the angle of projection is kept constant. By what factor does the range change? So if I just write that down again, the sine of 2 theta, and that's all over g, but r is proportional to v squared. And therefore, the factor, if this doubles, then if you multiply by 2 and square the 2, you get 4. So the factor is it increases by a factor of 4. One of the reasons for Wellington's victory at Waterloo was that English field guns were much lighter and hence more mobile than the French. The muzzle speed of a shot from an English gun was about 150 metres per second. At what angles with the ground could an English artilleryman have trained such a gun at a target 1200 metres away? Assume the ground was level and neglect air resistance. So what angles means we're looking for 2 angles. So whenever we find the sine of 2 theta and find a value for 2 theta, we have to remember that our 2 values could be in either the A portion of your the A portion of the cross there, or could be in this portion here too. So we'll just do the calculation first. We know that r is 1200 metres, and we're looking for sine of 2 theta. So rearranging that equation, sine of 2 theta is rg over v squared, which is 1200 by 9.81 divided by 150 squared. And when you take the inverse sine of that, you'll find that 2 theta could be equal to 31.5 degrees, or, so this is found in here, the 31.5, or it could also be found here. This would be the 31.5, so that would be 180, take away 31.5, so that's 148.5, and therefore theta is going to be equal to half of those, so that's 16 degrees roughly, these are rounded up, and 74 degrees are your two answers there.